When you visit us here at the Royal Observatory in Greenwich, you might notice this on display. But what do these numbers mean? Why are they important? And why are people buying t-shirts with them on? To answer this, we'll need to zoom out a bit. The equator splits the Earth into the northern and southern hemispheres, and we draw lines of latitude parallel to it. The observatory is 52 degrees north because it's 52 degrees north of the equator. To measure east and west, we use the Prime Meridian, which runs from the North Pole to the South Pole through Greenwich. We draw lines of longitude parallel to it. Here in Greenwich, we're on the Prime Meridian, so 0 degrees. Other observatories around the world can be located by their own coordinates. Coordinate systems are excellent for locating positions on Earth, but we also need a system for the night sky. Let's start with the horizontal coordinate system. Altitude is the angle from the horizon to the object. It goes from 0 to 90 degrees, which is directly overhead and known as the zenith. Azimuth is the angle between the object and north. From this observer's location, the star Betelgeuse has an altitude of 45 degrees up and an azimuth of 192 degrees measured clockwise from north. This system only gives the coordinates from one particular location on Earth at a particular time. An observer in another part of the world would have to calculate their own coordinates to find the same object in the sky. Enter the equatorial coordinate system. The celestial sphere is an imaginary sphere around the Earth. Stars are located at different distances from the Earth, but we imagine them all on this sphere to make things simpler. We split the sphere into two halves using an extended plane of the Earth's equator, the celestial equator. We measure objects north or south of it. This angle is called declination, and it's measured in degrees. This is the celestial equivalent of latitude. Now we need to measure the celestial equivalent of longitude. We can't use the Prime Meridian, as it moves as the Earth spins. Astronomers have picked another location called the first point of Aries. This is where the equatorial plane crosses the ecliptic plane. The ecliptic plane is the plane the Earth is in as it orbits the Sun. Because of the tilt of the Earth, the equatorial plane and the ecliptic plane are different, but they cross. We measure anti-clockwise from this point and call this right ascension. Right ascension is measured in hours, minutes, and seconds. The 24 hours Earth takes to spin round is equivalent to 360 degrees. Betelgeuse is 7 degrees above the celestial equator and 6 hours anti-clockwise from the first point of Aries. If we move to a different part of the world, the sky will look different, but any object's position, measured by the equatorial coordinate system, will be the same. And now, astronomers around the world can communicate.